burden.
Are we going to come across a situation where you are going to be faced with building and assembling an assembloid that will just be too...
And, while like many of the features of this assembloids are really fascinating and surprising, they still have a lot of limitations. They're not vascularized. They don't receive blood supply. We may be able to stimulate them with like capsaicin or something else, but they're not receiving the rich sensory information that is important. Think about if you have a kitten where you cover one eye, if you cover that eye for a week, that cat will never see with that eye. You do it in an adult cat for a week, no problem whatsoever. So early in development, if some of the circuits do not receive the right input, they won't develop properly. So, again, while our models are relatively complex already, they lack a lot of the complexity. And, is as George Boggs famously said, that all models are wrong, but some are useful. And the models that we make are not, our goal is not to make a perfect model of the brain. It's like to make a good enough model of a part of a brain or of a circuit that will give us the breakthrough therapeutically.
I wouldn't be so harsh with the term model there. I would say all models are almost by construct incomplete.
Right.
But that wouldn't make them wrong necessarily. Yeah. They're not the whole story. That's why they're a model.
That's why they're a model. Because
otherwise, it would be the exact thing.
You wouldn't need it. You wouldn't need a model if you could replicate the exact thing.
It would be the thing itself.
Yeah, right. Yeah. Okay. Yeah. I just love that Assembloids sounds like a Cartoon Network show. Like Assembloids weekdays at 3, right after Transformers. It
actually turns out that there is a game. There is a video game for it, which I didn't know when I put out the term, but there is a very popular video game that is literally called Assembloids.
Cool.
Where do we hit the ethical wall and hit the regulatory and all the other things? And
did you say regulatory?
I did.
This is America, Jack. It's regulatory.
Regulatory. Not even regulatory.
I didn't come here for a lecture on geography. I know it's America.
It's America, Jack.
Anyway, okay. You were saying.
We think about this like all the time. Honestly, in the beginning, obviously there are like not that many ethical issues, but as we've progressed, it becomes clear that we have to think carefully. So they're like, the way I think of it is like in multiple levels. Like on one hand, there are like issues about the cells. These are human cells that we're using.
Yeah.
Who owns the cells? You have to give consent for this experiments to be done. And we do that all the time. And so we always have to put that into the context of like, what are we doing with the cells, what the cells were consented for?
That's very much like, who is the woman who...
Lax.
What's her name?
Lax.
Lax, yes. Whose cancer cells were... Whose
used
cells were used for decades and saved and created many breakthroughs in cancer, and the family got nothing. And she never gave permission, so it's good to know you're doing that.
And that's why it's critical. Every time we collect the skin...
Henrietta Lacks, yes.
The patients or, the parents, in the case, if they're minors, will actually be clearly informed about what will happen with the cells, how the cells will be shared with others, for instance, under what conditions, and so on and so forth. So on one hand, there are like these issues about the cells. Then sometimes, as you know, we're using animals. So sometimes we transplant this into the animal. So we also have to think about the welfare of an animal. You transplant more, is the animal suffering in any way? And then the third problem, which is perhaps the more kind of like philosophical in a way, is like, are there any new emergent properties? Like, are there, features, complex features that are arising from this that would make one think that we need to regulate this field? Currently, I think the models that we have in vitro are not sufficiently complex to justify, the presence of any complex features. So that's why we don't use the term generally, the term intelligence for this, because intelligence is really a property of an organism. It involves like goal-directed behavior, it involves learning. None of our cultures do that. And using, anthropomorphizing, it's not generally a very useful thing to do in this case. But as the models become more complex, we have to start having these conversations. And that's why, last year we had an Astillamar meeting, which is like this historic place here in California, you may have heard, where many of these ethical discussions have started in biology. In the 70s, when gene cloning was so like discovered, then everybody was like, what is going to happen? We're now modifying these genes and we're going to create new organisms. So scientists got together there with philosophers, with journalists. So that's what we're also doing now. We're getting together a larger group and thinking, what are some of the implications? sociologically, religiously, philosophically, while at the same time thinking that psychiatric disorders are a huge burden. And if you have a technology that has the potential to change that, to provide cures, is it, unethical not to use it, right? I mean, there's even that argument, where, how far do we go in that? So those are like ongoing discussions. I mean, it's been really interesting. I spend more and more of my time as part of these conversations.
Let me take just one other place before we land the plane here. You came into this as an expert in the autism spectrum patients.
Yes.
And a new term that's been bandied about for the last certainly 10 years is the concept of neurodiversity. When you look at it that way, who is anyone to say that someone needs repair if they're simply manifesting on a spectrum of neurodiversity?
Sure.
Your counterparts not long ago would have labeled homosexuality as a mental disorder in need of repair. And only recently, in historical times, recently, was that removed from the list of human maladies and disorders. So there's another ethical frontier about what it is you judge needs repair versus is just another kind of person.
And that's absolutely one of the discussions that we've been having, one of the ethical discussions that we've been having. And all psychiatric disorders are on a spectrum with the population. And some of them are more severe and some of them are less severe. And that's also the case for autism. Autism is certainly a spectrum, but what we're focusing on is actually what we now call profound autism. This is the autism that is really debilitating. So patients with Timothy syndrome, or like some of the other patients that were like with other disorders, can have 60 seizures a day.
Oh my.
Really?
Okay?
That's just
They
awful.
are unable to make any eye contact. They need a caregiver for the rest of their life. The biggest fear that a parent has when they have, a child is like, what if I die? So I am seeing it through the eyes of some of these parents that are dealing with like really the devastating forms of autism, what we call profound autism. And then of course there is like what you mentioned, which are neurotypical or aspects of how we interact with each other that do not require nobody wants to cure or to provide treatments for anybody, but these patients are severely affected. Most patients with psychiatric disorders are severely affected.
So I once asked Oliver Sacks, who is a friend of our show, we have some archival content with him.
Oh, that's amazing.
Yeah. I asked him after a public talk that he gave, if you could go back in time and carry with you a pill that would cure your own ailments. He had sort of certain neuro issues. He has, correct me on the word here, prognoplasmasia.
Yes, he did. Yeah, he couldn't really identify.
Yeah, he had face blindness. Okay.
Yeah.
Oh, wow.
And some other elements to it.
I
And
sometimes wish I had that.
So I asked him, if you could take a pill that would just cure that back when you were 17, would you? Looking back at that time. And he said no, because it was those differences in the way his mind worked that got him interested in neuroscience to
In the
begin
first
with.
place, right.
That was his destiny.
But you see, that's exactly the point where we started. Like, the beauty of like building a nervous system is that while there is a basic plan that makes our brains the same, we pretty much can do the same things. It also creates a lot of diversity. Even monozygotic twins, right? They have the same genetic material. They share the same womb.
Yeah.
And then they can have different sexual orientations. They have different hobbies.
They have different fingerprints, if I remember correctly, don't they?
They do, yes.
Wow.
Because
Yeah.
again, there is a lot of stochastic forces in development. And those are the ones that make us different. And that's how evolution actually works too. By selecting these differences that, to a large extent, probably that's what made us as a species so successful.
Yeah.
The fact there is always an individual who has a vision, who wants to go and, discover a new continent.
Yeah.
So I think that's the power of our species. And I think I know very few, honestly, psychiatrists or neurologists who would want to cure that or change that.
Right.
I think what we're dealing really on the field is really these devastating conditions that make essentially most of these children unable to really function as adults. or as children.
So this is a very human-centric view. So if you were the COVID virus, you would say, let's invent humans who then have airplanes so that we can cross continents and affect other people.
Absolutely. They are the true owners of this planet.
That's right.
Let's be honest. Viruses.
The viruses.
They're true owners of
You
this
said it,
planet.
microbes, we're just an Uber.
Yeah, that's all. For
Uber.
microbes, we're just an Uber ride. That's all we
Uber
are.
ride. Well, Sergio, it's been a delight to have you on Star Talk, sharing your expertise with us and taking time out of what we know is your busy research schedule to give us a little glimpse into what you're doing in your lab. Just congratulations to you and all the people who work in your lab, who are surely working there right now while you're talking to us.
Oh, they are right here. I mean, yeah, and really, they're the ones that are doing all the work. I mean, this work. I mean, hopefully, it came through from the discussions, but these experiments are long. I mean, they last hundreds of days because human development it takes a long time. So it requires a lot of dedication. But I think the promise of what this could yield ultimately, understanding the human brain is addictive. So you really want to figure this out.
Well, thank you again. I'd like to reflect on this with a brief cosmic perspective, if I may.
Please.
This moving neuroscience frontier has got me thinking.
I owe you one.
You look at the progress of civilization. It always comes about when we have the proper match between a tool and a goal. And when they come together, we build things that didn't exist before. Or we disassemble things that had never been taken apart before. But in all cases, it has to do with the precision of the tools you bring to the task. And to learn what's going on the frontier of neuroscience, it feels to me that it's finally catching up with the methods and tools that have shaped. Engineers built dams and buildings and aqueducts and everything that we value and care about in our modern life. But the time has come to care about what's going on inside our brain, within our mind. And I'm delighted to learn that that is a frontier that finally has tools befitting the task. Welcome to the club, neuroscience. And that is a cosmic perspective. Keep looking up.
What is emergence?